Okay, ladies and gentlemen, so we are going to start a little bit of a sort of progression of what we've been doing in trigonometry. We're just going to be sort of looking at some of the proofs, trigonomic, identities. Okay, so we're just going to sort of have a look at this, and it all starts when you have a circle. So some person out there drew a circle. Doesn't matter, it's not that circular, and then decided to draw a line and call that the radius, and that's also the radius. And then what you can do with that is you then draw a right angle triangle down to here. So now you need to refer to this point as x and y. Okay, so that's to suggest that the height is at height y. We don't know a particular number, and the x, we're x along here. Okay, so we're just calling x and y, so that's why you got that coordinate. What else can we do? We can call this angle theta. Now, what can you do with the information that we've got here? Well, we can come up with the equation of a circle using Pythagoras. So first of all, let's take the sine. Okay, we want to find sine theta. Okay, so basically we're going to find sine theta, cos theta, and tan theta, and then see what we can do with all that information. Right, so what is sine theta? So we know that sine theta is opposite over hypotenuse. So the opposite is this line here. So we need to denote this, and we've already said that because this point is x and y, that this whole line is just going to be y. Okay, so we have sine theta is y over the hypotenuse, which was r. Okay, let's do cos theta. So cos theta is ca adjacent over hypotenuse. So we're looking at this angle here, this line here, sorry, and we've denoted that as being x because, as you can see, we had y, which was up that length, and now we've got x, which is here. So we just call it x. Of course, this whole line is equal to r, because if you were to measure this line, the radius is r all the way around the circle. But we don't want this line, this little gap here. We just want from there to there, which is what we've called x. So anyway, adjacent, which was x, over the hypotenuse r. So there we go. There's cos theta equals x over r. So let's do tan theta. Tan theta is toa sokato. So that's the opposite, which is y, over the adjacent, which is x. So there we go. So we have some information here. But what can we actually do with this now? You might wonder. You might ask. Well, let's have a look. So we can see that y over r, x over r, y over x. So if we were to, for example, get x equals, right, so what you can do is just a bit of algebra and just play around with it a little bit. Okay, so what if we just made r the subject? Let's do it like this. So we're working with cos, and so then that's we'll just cross multiply. That's cos theta. Okay, and then we'll get. So I wanted to get x on its own. Okay, so let's work with cos theta. first of all, and let's make x the subject of the equation. So we just want to take r over, so that's going to be r cos theta. Whoops, r cos, oh dear, disaster. But we can rectify it. Okay, r cos theta. And let's work with the tan, and let's make x the subject of the equation, so just in case of cross multiplying the two. Right, so in which case we can now say that r cos theta, because that equals x, and y tan theta equals x, we can put r cos theta equals y over tan theta. And what can we do with that, I wonder? So let's make y the subject of the formula. So we're just going to cross multiply. No, we're not. We're just going to take tan over. So that's going to be r cos theta tan theta. And let's work the signs out now. So let's just make y the subject of the formula up here. So that's going to be r sine theta. And now we've got so that means we can say we've got y equals r cos tan theta, and now we've got y equals r sine theta. So we can put that equal to each other. And let's see, what can we do with this? Let's just get rid of that for now and just focus on here. So what if we take the r cos theta over here? So you're going to be left with tan theta equals r sine theta divided by r cos theta, and let's cancel the r's, so you're just going to have 1 there, but we don't need to write that. So then you end up with tan theta equals sine theta over cos theta. Whew, that seemed like a lot of hard work to me. There is quite definitely an easier way to derive what we want to derive. So anyway, this is a very important trigonomic identity that can be used, and we'll see how this will be used shortly. So we're going to leave it for now, and then you might want to sort of review this video in sort of future to see what I was even doing and why I was doing it, because if I was watching this for the first time, I've just seen a bloke just draw a circle, come up with these random sort of equations, and then he's just all of a sudden he's messed around with it and put something equal to something equal, and then ended up with tan theta equals sine theta and cos theta, and if I didn't know any better, I would have just sort of I could have quite easily gone from here and just taken that over, gone r cos theta tan cos theta over r sine theta equals to 0. Maybe we could do something like that, we don't know, but I already know that this is quite important, and this is what we were getting at with this video. So bear with me, and we'll do another video, and we'll see how sort of the work that we're going to subsequently do, how this comes into play. So see you in the next chapter, well, the next videos of this chapter.